Good afternoon, everyone. So, welcome to the 14th session of Small Talk series. Today, I am going to talk about how we can optimize SQL statements. So, in order to optimize SQL statements, we have several methods. So, first one is indexes. So, you already know about indexes, right? This is where we create indexes on tables so that we can provide an easier way for SQL to access certain data in the table. So, we can create multiple indexes on a single table. So, when we actually execute a query, optimizer will look at the statistics of the table and the list of indexes and decide which column should I use to access the data and which column should I use to filter the data. So, index itself is another data structure. So, it can utilize some certain amount of storage as well. So, if you create a good index, you can optimize your query, but if you have a bad index, it will just eat up your free space. So, the downside of an index is that it will slow down your DML queries by 4 times, especially insert operations. So, the other thing is that system variables. So, using system variables you can to certain extent you can fine tune your queries. For example, let us say be it Oracle, be it MySQL, there are a set of variables which governs the behavior of the database. So, we can actually modify those variables to match our use case. For example, you can change the isolation level of the database. So, based on your use case, or you can just resize the memory, certain memory components depending on your type of SQL you are using. So, other one is resource provisioning. This is pretty straightforward. You monitor your database, and if you see the maybe CPU or memory utilization is high, then you can just go ahead and provision scale up your instance. So, this is usually considered as the last resort. I mean indexes, system variables, those can be looked at first. So, I guess we are fortunate because we are in the cloud. So, provisioning new resources, scaling up is pretty straightforward. So, but if you are managing your own infrastructure, then this will not be that much straightforward. So, other one is to follow best practices when you write SQL queries. So, in this session I am going to cover a bit more on this topic. So, have a look at this statement. So, I am selecting all the data which satisfies where function column 1 equals to value 1. In this case, I have used a function on this column. So, what it does is that it takes all the value in this column, and based on the function I use, it manipulates the data and do the equal operation. So, sometimes we actually need to use a function, right. I mean when we need to convert string value into data type, or if we want to make it uppercase, lowercase, or maybe we want to trim the white spaces, in such cases we really want to use a function on this column. So, the thing is that using function on the column in the where clause of an SQL statement is not recommended. The reason is if we use a function on a column in a SQL statement, it will not take the index. So, eventually this SQL statement will do a full table scan. You know what full table scan is, right. So, it will inspect all the rows in the table. So, let us have a look at this DDL table structure. So, you just have to note only this column created. We have created date column which is in date time data type, and also we have an index on that column IDX created date. So, we have created date column which is in date time times data type and index. So, all looks good, right? So, let us go into the query. So, let us say I want to select all the data in this table which was created on August 23rd. So, what I have done is that I use date function to filter out only the date part of the column, so that I can do the equal operation. So, in here I use this date function on this column in the where clause. So, have a look at this execution plan. So, even though we have the index, it is not taken. So, key and possible key all are empty. So, it is doing a full table scan. So, what we can do about it? So, clearly we have an index, but it is not taking. What we can do about is that we can keep the column as it is. We do not change it. We do not use any function. We keep the column as it is, and we implement the same logic by other means. For example, we use the minimum date and the maximum date and use between operator. So, that is the logic is the same. In this case, as you can see, the index is being considered. So, this is this SQL only inspect only 200 rows. So, this is much better. So, let us take another example. So, in this table structure, you just have to focus on only the port. So, we have port column which is in varchar, and also we have a index on top of that column, all right. So, we have port which is in varchar data type, and also we have an index. Let us see how we can retrieve data. So, in this case I want to get all the data which satisfies this condition, port equals to 4568, all right. We have remember we have an index on this column. So, have a look at this execution plan. Even though we have the index on this column, possible key is there, but the key is empty. That means it is doing a full table scan. Can anybody suggest what is happening here? I mean, we have an index, but it is not being considered. Does anybody know? Yes. So, yeah. So, in this case, what we have here is that in port column we have character type values in the column, but at the right hand side what we have specified is that it is a integer value. So, in order to compare two sides, the data type should be equal. So, the database what it does is that during the execution time database convert this column data implicitly into the integer value. So, as you can see in here, in this case, this is actually what happens in the background. Database is implicitly converting the column values into integer before actually doing the operation. So, at the end of the day it is also a function, that is why the index is not being considered. So, what we can do about it? We can just restructure our query like this. We just have to convert the value we provide into character data type. We just have to put 2 single quotes for the value we provide. So, database does not have to do the implicit data type conversion. So, as you can see, the index is being considered and only 2 rows will be examined. So, the other problem is that derived tables. So, have a look at this first query. In the first query, we have actually we have two queries. One is the sub query and the outer query. So, when we actually execute a query with a sub query, what happens is that the database execute the inner query first and keep the result in the memory, and it will be the output to the outer query. So, this will result a high memory utilization. So, what we can do is that we can implement the same logic without using a sub query. So, this is a very simple example. I mean, in day to day life we come up with similar requirements. So, basically basically it is better if we can reduce the usage of sub queries. So, basically what we can do is that we using join operation on multiple tables, we can reduce using sub queries. So, now I will show you how we can actually inspect what is happening behind the scene when we execute an query. So, what you have to do is that you have to first say set profiling equals to 1 before you run your queries. You have to say this is actually MySQL specific commands. So, other query optimization suggestions it's apply those are in general. This is sort of MySQL specific. So, what you have to do is that you have to say set profiling equals to 1. So, this will enable query profiling. So, then you can execute your queries. In this case, I have executed the same query twice. Select all from printers where port equals to 4568, and again I have executed the same query. Alright. So, after that you can say show profiles, then all the profiles will be shown. In this case only 2 profiles will be shown here because I executed only 2 queries. So, it has query ID as well. So, if you want to get more information about the queries you execute, you can say show profile source for query 1. This is for the query 1, and I have executed again for the query 2. Remember the both queries are exactly the same, but have a look at the backend steps. Those are different. For the first query, we have lot of steps. For example, checking query for query cache and permission, opening tables, lot of steps are there. But in the second query, there are no many steps. So, as you can see, in the second query, checking query cache for query, checking query cache for query. So, that in this case it is a success. That means, since we execute the same query twice, the result of that query is already there in the query cache. So, in this case, database can just get the result out of query cache and send it to the client. So, using query profiling, you can actually identify what is going on the background, and as well as you can identify the bottlenecks your query has. So, based on those insights, you can implement best practices or index methods. That is pretty much it from my end. So, okay, thank you.